Hi and welcome. Today, in this video, we would be discussing about some basic concept of chemistry, which is Unit 1 over there in your class 11 chemistry textbook. Here, in this unit, as the name suggests, we would be discussing some terminologies, basic terminologies or concept that we would be using in the further units or in the further class levels of your chemistry domain. So let's see what all are the subtopics and the topics that we would be discussing over here. Weightage and topics. So as you can see, generally 5 marks is given for this particular unit in all the boards, in almost all the boards over there working in India. 5 marks is what it is given over there for this particular unit. But however, it can vary like 4 marks or 6 marks or 7 marks or something. But on an average, it is 5 marks. All right. And in this particular unit is again subdivided into further subunits like importance and scope, classification of matter, properties of matter, uncertainty in measurement and significant figures, laws of chemical combination, dimensional analysis, Dalton's atomic theory, mole concept, balancing of chemical equations, and stoichiometry. However, all the topics that are given over here, out of these, the first few topics till here, they are introductory topics. They are known as introductory topics, and they won't be asked. They are not of much importance for us, but these are of great importance. Like these topics, these down topics, the topics which are at the down part are is of much importance than the first one. The reason we are learning the introductory topic is to understand the last few topics. We need to understand the introductory topics first. So that is why we are learning the introductory topics. All right. So first, let's understand what the first part, and then we would be coming towards the last four parts. In this video, we would be discussing about these two, the importance and scopes of chemistry and classification of matter. And again, this particular chapter is further subdivided into different videos. So yeah, so in this video, we would be discussing about importance and scopes and classification of matter. Chemistry has been used over there in almost all around the world. It has been used in each and every single time or each and every single part of our lifetime we are using chemistry, right? For example, if you're talking about in terms of supply of food, if you want to uh, preserve a food or food item or anything, you again need to use some preservatives in it. Preservatives means those substances which will be allowing it to not to decay faster. So preservatives, we would be using chemistry over there to understand what kind of preservatives can be added to a certain kind of food and all. So we are using chemistry over there. And again, the lace packet that you're using, it is containing nitrogen gas in it in order to ensure that it won't be reacting with oxygen. The chips won't be reacting with oxygen and it would be getting oxidized. We don't want that to happen. So that is why we are filling it with nitrogen gas. And then comes in contribution of health and sanitization. So you know how important it is right now in this pandemic moment. And sanitization, we are using it like alcohol sanitizer and all these kind of things we are using right now to keep the germs and other things away. And again, disinfectants we have been using. And again, it is upon the chemistry. And in health, drugs are used, different kind of drugs that we have been using. So all these are a part of our all these are coming out of chemistry. And then comes in environment. Previously we were using CFC as our coolant in refrigerators and all, but right now we found that CFC is not environmental friendly, so we use freon gas instead of it, which makes it, freon gas is much environmental friendly and we are using freon gas right now. So we found an alternative for CFC, which is again a part of chemistry. So it is used in environmental friendly items also. So then again, in increase in comforts, there is something known as carbon fiber, which is light in weight and strong and durable, very highly strong and durable. So this particular thing is expensive, but yeah, it increases the comfort of all. Like in cars and all, people have been using it right now in Tesla cars and all. So yeah, so it helps in increasing the comforts. Then in transport and communication, like in petroleum products and all, we will be using chemistry over there for extraction of these petroleum products. Nuclear energy, atomic energy, again on the basis of atoms, like in fusion, through fission and fusion, we will be making energy out of them, right? So again, there we are using these chemistry. In industry and war, again, we are using chemistry, like in making weapons or anything, chemical weapons or anything, we are using chemistry. Over there in industries, Like if we need to produce some chemicals like fertilizers or anything, we again need to, the industries are using chemistry over there. So again, to clean the harmful things that is coming from the industries and all the harmful waste which are coming from industry, we are using chemistry there, like our catalyzers and all. So this is how it works. So this is the importance and scope of chemistry. So let's go to the next slide and understand about classification of matter. Classification of matter. Before going to classification of matter, let's first understand what matter is. What is matter? Matter is anything that occupies space and have a definite mass. So for example, from a dust particle towards sun, earth, moon, or anything, all of these things are considered to be matter because they are occupying the space and they are having a definite mass. So they are considered to be what? They are considered to be a matter. At the same time, to understand more in depth about matter, we started to classify the matter. All right. So there were two ways for us to classify matter. One was the physical classification and the other was chemical classification. So there were two ways, physical and chemical classification. Physical classification was on the basis of the physical conditions like temperature, pressure, and all. On the basis of it, we started to classify them like solid, liquid, and gas. We classified them as solid, liquid, and gas. So you know what solid is. Solid is any substance that is having a definite volume and a shape. This particular character of them, like this definite volume and shape, is only because of the closeness of the arrangement of their molecules. Like the molecules are arranged or closely packed among themselves. So that is why it is having a definite volume and a shape. But over there in liquids, it is having a little bit space in between, or degree of freedom is a little bit more, which makes them move here and there in a liberty, like it is having a little bit more liberty to move here and there. So it makes it to not to take a particular shape, or it can take any shape it needs, but it has a definite volume. It is having a definite volume, but it doesn't have a perfect shape. So it takes the shape of the container that it is stored in, or the thing it is stored in. It can be anything. All right. Then in gas, it is neither having any definite volume or a shape due to its space between different atoms or different molecules are intermolecular space is too high. All right. So because of them, they are having high degree of freedom or high degree of movement and all. So what they used to do over here is they will be taking both the volume of the container and the shape also of the container. They take both volume and shape of the container. So to convert a solid to liquid, we used to heat them, right? To convert a solid to liquid, we used to heat them. Similarly, from liquid to gas, if we need to convert, we used to heat them. In the same way, if we need to convert a gas to liquid, we will take heat from them. We don't give them cold, we will be taking heat from gas, then we will be getting liquid. There is nothing known as cold, giving cold. There is nothing known as giving cold. What we are doing, we are taking heat. We are taking heat from them. So liquid, gas to liquid, we are taking the heat, and from liquid to solid, if we need to convert, again, we will be taking the heat from it. From liquid, if we take heat from liquid, we get a solid. All right. Now the next thing that we will be studying is about the difference between vapor and gas. Vapor and gas. So you might have noticed we call water vapor a vapor, but not the oxygen. Right. The reason is very simple. Water is liquid at room temperature. Water is liquid at room temperature, but oxygen isn't. So any substance that is a liquid at room temperature and gas when you increase the heat, then it is known as a vapor. All right, a gas who is liquid at room temperature. A gas who is liquid at room temperature is known as a vapor. Similarly, a gas who is gaseous itself during room temperature is known as gas itself. All right. So this is the physical classification. In the next part, we would be dealing with the chemical classification of the matter. Chemical classification is done on the basis of phases it is having, number of phases a particular matter is having. For example, if I'm talking about kind of like if there is sugar solution, consider there is sugar solution. So in sugar solution, you know that every water molecule over here, there will be a water molecule and a sugar molecule will be attached towards this water molecule. Everywhere it would be like that, sugar and a water molecule. They will be attached everywhere, it would be same. So they are having a uniform composition everywhere, like only one phase is there everywhere. But at the same time, I started to mix sand and salt. I started to mix them. So in sand and salt, you know that if I mix them, it won't be uniformly mixed. If sometimes here it might be sand, might be more, or here it might be salt, or some kind of irregularity would be definitely present over there in this particular mixture. So phase, there are multi-phase over here. There are multi-phases over here, while there is only single phase over here. Again, in oxygen gas, only oxygen would be present over there, right? Only oxygen will be present over there. So it is again having only one single phase. Similarly, over there in air, even if you take the air over here in, like I'm from Kerala, so the air over here in Kerala contains same amount of oxygen, like 21%, right? And air over there in, if you take Kashmir also, it would be of the same composition. Even if you take the air over there in London or US or anywhere, the composition would be same. Right. So their air is having a unique composition or same composition, hence it is having only single phase. All right. So it is the uniformity of the composition. Phases means uniformity of the composition. Similarly, another example I can give is about milk. So in milk, as you can see that if you're taking a small part of milk, you can see calcium, fat, minerals, everyone, like all these kind of minerals together, right? Every one of them will be together. Even if you take here also the same components, you would be able to see here also. Here again, you would be able to see the same things over there also. So this is a kind of single phase. Milk is a kind of single phased substance. All right. So generally, on the basis of this phase, we started to categorize them as homogeneous. Matter was classified as homogeneous mixture in the beginning. Okay, this was in the beginning, homogeneous substances and heterogeneous substances. But then we found that this is not a proper classification. Homogeneous substances are those substances which are having only one phase. It could be sugar solution, it could be oxygen gas, it could be air, it could be hydrogen gas, it could be anything. While heterogeneous substances are those substances who are having multiple phases in them, like sand mixture, sand plus uh, salt mixture, or a salad which contains cucumber, carrot, and all other kind of things in it. So that is also heterogeneous mixture. So what the main point over here is that this was not a kind of proper classification according to scientists, because it was not that intense. So what they did was they said we have to classify them according, not according to the phases, but according to the substance. All right, so they classified it according to the substance. Matter was further divided into two, as one is pure substance and another one is mixture. So pure substances are substances who are having only one kind of particle in it. Pure substances are substances who are having one kind of particle in it. For example, if it is water, it should contain only H2O in it. H2O. No, nothing else. H2O, H2O, H2O everywhere. Nothing else. Alright. In mixtures, like our sugar solution is a mixture because of the fact that it contains H2O and a sugar molecule. Everywhere you can see H2O and a sugar molecule. H2O sugar molecule. It is like that. It is dissolved in it. Right. So mixtures are those substances who are having more than one kind of particles, but in pure substance you will be having only one particle. Pure substances were further divided into elements and compounds. Pure substances were further divided into elements and compounds. We would be discussing about elements and compounds later. Similarly, mixtures were also divided into heterogeneous mixtures and homogeneous mixtures. Homogeneous mixtures, heterogeneous mixtures. So pure substances, as you know, it is having only one phase. If you're taking water, only water will be there, right? So it is having only one kind of particle or one kind of phase. Everywhere you take, here also it would be H2O, here also it would be H2O molecule. So this one is actually a homogeneous substance. Okay, this is a homogeneous substance. Pure substances are always homogeneous, while mixtures can be homogeneous or heterogeneous. So let's learn in deeper about each and every single uh, sub classification of pure substances and mixtures. Again, this is the flow diagram of it. Like matter, I told you, I showed you how it looks like, the division of it. Matter is divided into two: pure substances, mixtures. Mixture is again divided into homogeneous and heterogeneous, while pure substances are divided into elements and compounds. So this is how it looks like, their classification. So pure substances are having only one kind of substance or particles in them, like you're taking water molecule, while over here mixtures, they are having a load of substances in them. Like in terms of sugar solution, it is having both sugar and water in it, not just water molecule. Okay, so yeah, this is the kind of flow diagram, and let's go to the next one. So pure substances are those substances which are having only one kind of particle in them. I have told you, like for example, like if you take water, it should contain only particle as in molecule. Consider particles as molecules here. Okay, so if it is having only one kind of molecule here, if it is having only water here, then it is a pure substance. Why don't we consider sugar solution as a pure substance? Because it is also having into this water molecule, sugar molecules are dissolved. Okay, in this solution, with the water molecule, sugar particles are dissolved. So even here or anywhere you can find the same thing. So that is why we are not considering this as a pure substance. But water is considered to be a pure substance because only because of the fact that H2O molecule is everywhere. Everywhere you see H2O molecules. All right. So H2O molecule here, H2O molecule here. So again, it is a homogeneous mixture because it is having only one phase, unique composition. Everywhere you will be seeing H2O only. So it is a homogeneous substance, but it is considered to be in pure substance just because of the fact that it is having only H2O molecules. No other molecules are attached with it, or it is having only a component as H2O. So pure substances, like again oxygen cylinder is containing oxygen gas, means it would be having only oxygen, right? So the gas of oxygen is the oxygen cylinder, the gas inside this oxygen cylinder is an example for our pure substance because it contains only oxygen in it. It doesn't have any other molecules attached to it, right? So again, these pure substances were divided into two parts. One is element and another one is compound. What is an element? It is the simplest and basic form of a substance. Simplest and basic form of a substance which cannot be broken down and contains only one kind of particle. For example, here we are having two kind of particles. See, H is there, O is there, so it cannot be considered as an element. It should have only one kind of particles, like H alone is an element. H2 alone is an element. O2 alone is an element. Fe is an element. Then anything, like there are 114 elements. So like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, all these things are elements. So they are containing only, they are made up of only one kind of particles and they cannot be broken down anymore because their properties will become invalid then. All right. So some particles, they exist as single atoms, like in terms of ion and all, they will be existing as Fe, like single atom. But over there in hydrogen, hydrogen exists, does not exist as a single atom, but it exists as H2 molecule. Okay, they exist as H2 molecule. So up till now, we know 114 elements, out of which 96 are available on Earth's crust, and rest are made by nuclear reaction. We used to do it in chemically, we artificially make them. All right. So elements are again classified into metals, non-metals, and metalloids. You can see the periodic table and their classification. We would be learning about all these things in another unit. Until now, or till now, we don't have to focus upon it in this chapter. Okay, so here uh, we discussed about pure substances and their divisions, elements, and compound. But we discussed about element, and in the next slide we would be discussing about compound. Compounds. So over here we would be discussing about compounds and their properties and all the things related to compounds over here. Compounds are what? The substances which are containing more than one kind of atom or element in a fixed proportion of mass. Let's take an example of H2O. So H2O, there are two elements over here, hydrogen and oxygen. Hydrogen and oxygen combine to form H2O, right? So over here, in the same thing, like mass of hydrogen is 2. Mass of hydrogen is 2, and there are two hydrogen atoms, so 2 into 2, and oxygen's mass is 16. So they combine in a ratio of 4 is to 16, which means 2 is to 8, which means 1 is to 4. So this ratio, if you're mixing hydrogen and oxygen, you have to mix them in this particular ratio to get water. You cannot mix like, okay, 5 is to 10 or something like that. You cannot mix 5 is to 10 or something, which means 1 is to 2 again. You cannot mix it in that way. Or 5 is to 9, even you cannot do it. It has to be in this particular ratio, or anything that is complementary towards this ratio, like 2 is to 8, or 4 is to 16, 5 is to 20. Yeah. So you have to mix them in a particular ratio itself, in a fixed proportion of mass. Matter can be decomposed into its constituent elements by chemical methods only. You cannot just pick a like oxygen and hydrogen from water using your hand or anything. You have to use some chemical methods, like you have to pass electricity towards it, then only it will be getting decomposed, right? So this is why we call it as compounds. You cannot directly pick it using your hands. You have to use some chemical methods to convert it into its constituent elements. Now, properties of this particular compound or this particular material, if you're taking H2O itself an example, you can see that hydrogen, it is water's properties are entirely different from that of hydrogen and oxygen. Hydrogen and oxygen both are gas at normal temperature, but our room temperature, hydrogen and oxygen both are gases, but over there in water's condition it is liquid. So their properties are entirely different. All right, when it comes to a compound, their properties are entirely different. Again, the compounds are divided into two, organic and inorganic compounds. We would be dealing about organic and inorganic compounds about it in like in other units. Till now, in this particular unit, we would be learning till compounds only. So let's see what mixtures are classified into, and let's learn about them. Mixtures are again classified into two different types. One is homogeneous mixture and one is heterogeneous mixture, right? So in this particular slide, we would be dealing with homogeneous mixture. What are homogeneous mixtures and their properties related to it? So homogeneous mixtures are mixtures who are having only one phase. For example, sugar solution. Of course, sugar solution is considered to be a mixture because it is having two different particles, right? So sugar is here. If you take here, you can see that water molecule will be attached towards the sugar molecule. Similarly, over here on this side also, water molecule will be attached towards a sugar molecule. All right. So this is the kind of relation that they're having. Like everywhere you will be having one single phase. All right. So it is having a single phase everywhere throughout. Throughout the component, you would be seeing only single phase. All right. So this homogeneous mixture can be liquid, gas, or solid. So for example of gases, I can say air. Air contains everywhere. Air contains everywhere in the same proportion. I told you the case of oxygen's case in the previous slide. Like oxygen is 21% everywhere, no matter what. Similarly, in petrol, it is made up of different kind of hydrocarbons. Different kind of hydrocarbons. All right. It's a mixture of hydrocarbon. And then comes these are the example for gases, air and petrol. In terms of solid, alloys are what? Two different metals, when they combine and they give the properties of both the metals, we call it as an alloy. Generally, we do it in order to ensure the strength of one metal and the weight of another metal. Like if we want the resulting product to be lightweight and strong, then you mix two metals of different kind and you will be getting the desired property, whatsoever you want. All right. Then comes the sugar solution. Sugar solution is an example for liquid version. We discussed about sugar solution here. So generally, all homogeneous mixtures are known as solutions. No matter what, we call them as solutions. Remember this because we need them after some slides. So all homogeneous mixtures are known as solution. When we make any kind of solution, we can mix them in any proportions, but only in terms of gases. When we make any kind of solution in terms of gases, you can mix it in any proportion. Like you can add oxygen of any amount, you can add hydrogen of any amount. But over there in liquids and solids, it depends upon their mutual solubility. Because, for example, I cannot add like a lot of sugar towards this much liquid, right? If I add a bulk of liquid towards it, like a 5 kilogram liquid towards half liter of water, it is total stupidity, because it won't be it won't be getting mixed properly, right? So it won't become a homogeneous mixture though. So it depends upon the mutual solubility. All right, the mixing proportion depends upon the mutual solubility. So yeah, that is about it in the homogeneous mixture. Let's go to the heterogeneous mixture. Heterogeneous mixture. Heterogeneous mixtures are those mixtures which are having distinct phases. Like, for example, if you want to talk about sand and salt combination, they're having different phases. If you take here, sand might be more. If you take here, salt might be more. If you take, I added a little bit iron on the top, so it might have iron here more. So it can be any situation. It can be of any situation. It can have different particles at different places, which means it is not uniformly distributed, which also means it is having different phases in it. So heterogeneous mixtures are visible through our naked eye or microscope, but homogeneous mixtures aren't. Homogeneous mixtures aren't visible through the naked eye or microscope. All right. Then comes an example is given over here is iron sulfur common salt mixture, and milk is a homogeneous mixture. It's not a heterogeneous mixture. So one example. So here you can see some of the examples. One is iron sulfur common salt mixture. It is having what it is having everywhere. It is having the like distinct particles, as I've told before. It is having different particles everywhere. Here it might be salt will be more. Here it might be like sand might be more, or here iron might be more. Right. Again, milk. It looks like it is a homogeneous mixture, but it is a heterogeneous mixture because of the fact that it can be seen through a microscope. Okay, it's the fats in it are suspended in a clear liquid. Okay, like if you take the fat and if you which are suspended, if you look it through a microscope, you can see the fat molecules properly. Okay, and then smoke is again another kind of heterogeneous mixture. Smoke is having carbon dioxide and air, and some parts carbon dioxide will be more, some parts oxygen uh, will be more. Sometimes carbon monoxide will be there. So carbon monoxide, again, it's a mixture of a lot of carbon particles, and it depends upon the kind of smoke it is produced. So all this is a kind of smoke is a kind of heterogeneous mixture because of the fact that it is having uneven distribution of it. All right. Then comes in terms of, yeah. Then comes air. Air, if we consider dust particle, then it is a heterogeneous mixture. If we don't consider dust particles, then it is a homogeneous mixture. All right. Generally, air is considered as a homogeneous mixture because if you're considering dust particle, you can distinctly see it using your naked eye. Right. The particles, you can see it using your naked eye. And again, it is not of the same. Dust over here in Kerala would be lesser than that of Delhi. So it is not uniformly distributed. Okay, then you can mix heterogeneous mixture in any proportion. If you want to add more like sand or salt or anything, you can add more sand or salt. If you want to add more cucumbers to your salad, you can add more cucumbers. Then to identify or to separate, to identify different particles of a particular mixture, a heterogeneous mixture, you can do different tests. For example, just bring a magnet over here. All the iron particles will be attracted towards it, and it will be going there, and it will be attracted towards it. At the same time, we can use these methods to separate the components also. Like this method, like this iron method, I can use it to separate the components. Like I can remove all the ions when I bring a magnet towards the mixture. Similarly, if I want to remove the salt, what I will do, I will add some water, then stir it. So the salt will be getting dissolved inside the water. Then I'll drain the water. I'll drain the water, and once I drain the water, I get the salt-free mixture here. Salt-free mixture. There won't be any salt inside it because all the salts are mixed in with this water. So this is about heterogeneous mixture also. Difference between mixture and compound. So here what we are going to discuss is about the difference between what the mixture and the compound. Let's see what all are their differences. Let's write here compounds, let's write here mixtures, and let's write here compounds. So the first difference between them is that the constituents of a mixture may be present in any ratio. You can add any amount of sugar, you can add of any amount of salt. So the ratio are different. You can, any ratio is fine over here, any ratio. Over here, a fixed ratio in compounds, fixed ratio by mass. The elements are combining in a fixed ratio by mass. In mixture, it may be homogeneous or heterogeneous. It can be homogeneous, it can be heterogeneous. But here, a compound will be always homogeneous because it contains only one single type of particle. The next difference is that the properties of a mixture are in the midway between those of its constituents. Properties are in the midway. It means that, I know that you are not understanding, but still somehow handle it. So for example, in terms of sugar solution, you know that it is having a sweet taste, that of sugar, and a watery texture, that of water. So it is in the midway. It is having both the properties. At the same time, over there in this compound, the properties are different from that of its constituent particles. Like in terms of water, hydrogen is having different property, oxygen is having different property, water is having entirely different property from both of them, right? And then the fourth difference is that the constituent of a mixture can be easily separated by simple mechanical means. Like I told you, either you can take it using your hand, so separation, physical methods. But here, separation is by chemical methods. Like you have to give electrolysis to separate hydrogen and water from water. So this is the difference between mixture and compound. So yeah, let's go to the next slide. Flow diagram. You remember we first divided matter into two: matter, pure substances, mixtures. Pure substances again divided into two: elements and compounds, while mixtures are divided into homogeneous mixtures and heterogeneous mixtures. So this is how it is divided, and that's it. So yeah, this is all about it in this particular video. So we discussed about, first thing that we discussed about was about the importance and scope of chemistry. Second thing, we discussed about classification. We went to detail about each and every single thing. What is an element, what is compound, what is homogeneous mixture, what is heterogeneous mixture. So yeah, catch me up on the next video. Till then, bye bye.